Hello everyone. Here in this video, we are going to talk about stationary waves. So what is a stationary wave? First of all, let us try to understand that. Assume this has a rigid support. This is also a rigid support. Between them, a tight spring is placed. So when you disturb this string somewhere, you can disturb it anywhere, but you assume that you are pulling it down at middle of that string. What happens when you pull it down at the middle is, pull it down or pull it up at the middle is, at the point of pulling, the disturbance is maximum. So what happens? Now it goes down like this. From here it is fixed. Here it is also fixed. So it will go like this. After reaching this point, it has hit a block. Obstacle is there. There is a kind of a fixed wall. So the wave cannot move forward further and then it comes back this way. So this wave is fixed between two rigid supports, this support 1 and this support 2. That kind of a wave is called something like a stationary wave. That's the meaning of a stationary wave. A wave that is fixed between two rigid supports is called as a stationary wave. The very important point I want you to observe is at the point of disturbance, wherever you have disturbed it, at the point of disturbance, displacement of the particle is maximum. Here or here, displacement is maximum. That point where the displacement is maximum is called antinode. And at the end of the wave or at an obstacle, displacement is here it is maximum, here it is minimum. The point where the displacement is minimum is called node. So displacement is maximum at the point of disturbance, and at obstacle or at wall, displacement is minimum, and that is called a node. So a stationary wave consists of a nodes and antinodes. Here in this is the basic way of vibrating a stationary wave, generating a stationary wave. And what you have noticed here is here number of nodes are 2, but number of antinodes is 1. Here is an antinode, here is a node. So be careful that this is the general in any of the cases, right? Now, so you know the meaning of a stationary wave. You also know that the stationary wave consists of nodes and antinodes. And I want you to know what is the distance between them, right? So I just want to continue the diagram, right? That part of the diagram is full. That's why I'll draw it once again at here at some other place. Yeah. This is how a stationary wave is formed, right? If you notice carefully, this is something like a crust. In an ordinary wave, there will be a trough also, which is not there here. So an ordinary wave consists of both crust and trough, that is this part as well as this part. The length of that wave, that ordinary wave, is called wavelength lambda. Wavelength is the length of a wave. A wave means a combination of a crust and a trough. But if you notice carefully, this part, half of the part, is not there in a stationary wave. There is only the first part that is there. So the length of this stationary wave part, as it is only half of the wave, it is half of wavelength. It's not a complete wave, it's only half the wave. So its length between these two is only lambda by 2. So what we can notice here, little carefully if we observe, what is the thing that you have noticed here is, this is a node, as I told you, this is a node. The distance between them is half the wavelength. So what we can say, distance between two successive nodes is half the wavelength, lambda by 2, right? Of course, that's the length of the string. That's where it is happening. We'll come to that point a little later. So this is a node. This is a node. This is an antinode. From node to node, lambda by 2. Now I want to know the distance between node to antinode. That's even the middle. Antinode is at the middle of this node and node. So the distance between node and immediate next antinode is half of that lambda by 2, that is lambda by 4 itself. That's lambda by 4. I want you to notice these basic things before we actually go and talk a lot about stationary waves. I also want to tell you that it's a wave, like a transverse wave in a stretched string. So its velocity of the stationary wave is root of tension by mu, where mu means linear density of that wire, that is mass per unit length, mass per unit length of that wire. Well, that's basic aspects of a stationary wave. Depending on where do you disturb the wire, it can have modes, different modes of vibration. It can vibrate at different places, and we can have different names for that. That we will discuss in a coming video. That's it now. That's it for now. Thank you for watching. Right.